Today we will discuss example 3.26 from modern robotics. See here, this one is fixed frame, XS, YS, S frame, fixed frame. This is the initial body frame, say B. This is the final body frame, say C. This body frame is rotated around this axis, coming out of the plane of board normally, and the angular velocity is 1 radian per second. This one, angular velocity is in this direction, so it is in Z direction. So Z component 1 and the X and Y component are 0, 0. This point, according to S frame, this point has coordinates 3.37, 3.37. This one. This is the position vector of this point. Axis is here. From initial position to final position, body is rotated by theta angle. If you observe theta, it is round about 30. Exactly 30. I have tried my best for the figure. And see this axis, this one, it is an angle of 30 degree for this line. And further rotation here, so it is, for this it is 60 degree. That is body frame is rotated by 30 degree, theta is 30 degree. Screw axis, S is omega V, where omega is 0, 0, omega 3 is 1. This one is velocity expressed in S frame, V1, V2, 0. Body is rotated this way. So this is the velocity of the body expressed in S frame. That is, if we consider body's origin is here, so this is 3.37, 3.37, 3.37i, 3.37j. But if we consider body origin here, and this is the position vector, if this one is P, then this one is minus P. So omega cross minus P, omega is this one, cross minus P, this way. This is omega and this is minus P. So omega cross this minus P is this direction. So this is the body's velocity expressed in S frame. How? This way. Body's velocity V is omega cross minus P every time. That is, if we consider body's origin at the origin of a fixed frame, this is true for linear velocity due to rotation. Omega in our case 1k cap cross, see figure, this one, see this one, position vector of Q is 3.37i plus 3.37j. So minus P is minus 3.37i comma minus 3.37j. K cross I is j, so minus 3.37j. K cross j is minus I, so plus 3.37i. We will written first one 3.37 comma minus 3.37. This is the velocity of the body frame origin expressed in S frame. So if we consider every time body is enough large such that body's origin is here, and if it is rotated by this angular speed, what about this point velocity? So this one is the velocity of body origin expressed in S frame. So 3.37 minus 3.37, it is matches with our theory. Now see, body frame it is rotated at a 30-degree angle around z axis. So TSB is cos 30 minus sin 30, 0, 1, 1, comma 2. This one is 1, 1, 2. So this one is 1, comma 2 coordinates. So 1, 2, 0. Z coordinate 0. This one is a new math set is 1. So cos 30 minus sin 30 is 0, 1. Sin 30 cos 30 is 0, 2. 0, 0, 1, 0. 0, 0, 0, 1. 1, 2, 0 is the body's origin expressed in S frame. What about TSC? For this frame, TSC is cos 60 because of it is at an angle of rotating angle of 60 degree anti-clockwise. So rotation matrix cos 60 minus sin 60 is 0. Sin 60 cos 60 0. 0, 0, 1. It is the origin of body frame expressed in S frame. See this one 1, 2. This one is so it is 2, comma 1 according to scale of my figure. So 2, 1, 0. Z coordinate 0 because it is in XY plane. So 0, 0, 0, 1. This one we are rotating body only. So 0 pitch. Pitch is 0. We seek the screw motion that displaces the frame at TSB to TSC. TSB to TSC. That is TSC. According to mathematics, TSC is e raised to s theta. It is rotation matrix. To convert B frame to C frame. So into TSB. Multiplying both the sides, TSB inverse. So TSC into TSB inverse equal to e raised to s theta into TSB inverse, but it is identity matrix. So as a whole, this term right side becomes e raised to s theta. So TSC into TSB inverse equal to e raised to s theta. We have this. We can find this one directly using this because of we have TSB and TSC. So we can find TSC inverse also. So TSB inverse also. So we can find this one directly using this. But according to geometry, twist matrix is omega. What is twist matrix? Twist matrix is omega V 0, 0. This one. This is a twist matrix. So this is the skew symmetric of omega, or omega is what? 0, 0, 1. So skew symmetric. Z component is omega 3, which is 1. So 0, 0 minus omega 3, 0, 0, 0, 0, 0. This is the skew symmetric of 0, 0, omega 3. And this is the linear velocity V1, V2, 0. X component, Y component, Z component is not that. So 0, 0, 0. It is from the geometry. We can apply the matrix logarithm algorithm directly to SC, to TSC, TSB inverse to obtain S, and therefore S and theta. So S is what? This one, skew symmetric, this one. 0, minus 1, 0, 1, 0, 0. 0, 0, 0, 0, 0, 0. Just a minute. I have made mistake. Just a minute. 0 minus omega 3, 0. Omega 3, 0, 0. Yes. 0. This is minus omega 3. So it is 0, minus 1, 0. Omega 3 is 1, 0, 0, 0, 0, 0, 0, 0, 0. This one 3.37 minus 3.37, 0, 0. And S, this is body twist, spatial twist matrix. And this one, omega 1, omega 2, omega 3, just twist matrix, twist, spatial twist. 0, 0, 1, V1, V2, V3 is 3.37 minus 3.37, 0. And theta is, because we are rotated 30 degree, so theta is pi by 6 radian, that is 30 degree. Now we will cross check how it works. This is the same example. Cross checking. Reverse. Okay. Now cross check the same example. This is stationary frame. This is body frame XB, YB. This is final position of the body frame XC, YC. 1 radian per second. It is rotated about this point. So from the geometry, see this one is at an angle 30 degree, and further this one is at an angle of 60 degree with original frame. This point is 1, 2 according to S frame. This one is 2, 1. So this one is 1, this one is 1. So this one hypotenuse dotted line, this. It is root 2. This one 1, this one 1. So this one as a whole, this angle 45. So this is 45 and this is 30. And this length 1, 1, so root 2. So this line segment connecting this origin to this origin is having length root 2. And it makes an angle 45 plus 30, that is 75 with xb cap. So x coordinate of this point in B frame is x equal to root 2 cos 75. That is root 2 into root 6 minus root 2 by 4. Root 2 common. So root 3 minus 1 by 2. That is root 3 by 2 minus 1 by 2. Now if we extend this line here, so this one is 30. So this one is also 30. But this one is whole angle is 45. So this one angle, this, it is 15. And this one is having length root 2. So y coordinate of this origin expressed in B frame is root 2 cos 15 but negative. So y is minus root 2 cos 15. So minus root 2 cos 15 is root 6 plus root 2 by 4. So finally we have minus root 3 by 2 minus 1 by 2. Now here this is Tsb. I have written as it is. This one is Tsb inverse using the formula R transpose minus R transpose into P 0 1. So I have calculated, you can check yourself, but this one is true. Tsb inverse. This one is Tsc and this one is Tsc inverse using the same formula. Now TBC. So TSC, TBS into TSC. This represents C to S and this represents S to B. So as a whole C to B. So TBC is what? TBS, TSC. But we have TSB inverse. TBS is TSB inverse. So we can write TSB inverse into TSC. So TSB inverse is this one. And TSC, that is this one. This is TSC. If we multiply turn by turn, first row, first column, first row, second column, first row, third column, first row, fourth column, pura as a whole. So we get this one, root 3 by 2 minus half, 0, root 3 by 2 minus half. Half, root 3 by 2, 0, minus root 3 by 2 minus half. 0, 0, 1, 0, 0, 0, 0, 1. If we multiply these two. See, this body frame, C is, if we rotate B by 30 degree, we get C. So rotation matrix for C to represent in B must be cos 30 minus sin 30 0, sin 30, cos 30 0, 0, 0, 1. This is the same, cos 30 is root 3 by 2, minus 30 is minus half. This one is 0, 0 as it is, sin 30 is half, cos 30 is root 3 by 2. And this one, x point of the origin of C expressed in B frame. And this is y coordinate of C expressed in C frame. And we have obtained geometrically, see here, x coordinate this, see this. This is x coordinate, root 3 by 2 whole, root 3 by 2 minus half. Now this is y coordinate of origin C, origin of C frame, expressed in B frame. This is minus root 3 by 2 minus half. So the theory works properly.